Assalamualaikum and good day. In the previous lesson, we have already learned how to solve homogeneous linear equations with constant coefficients. How about non-homogeneous linear equations? How do you solve non-homogeneous linear equations with constant coefficients? This is what been discussed in chapter 4.4. This equation, number 18, is described as an nth order non-homogeneous linear equation with constant coefficients. This equation is said to be non-homogeneous because the gx is not equal to 0. When we solve this non-homogeneous linear equation with constant coefficients, we will get the general solution, which is given by y of x is equals to yc of x plus yp of x. What is yc and what is yp? Yc is known as the complementary function. That is, it is the general solution of the associated homogeneous equation. Equation number 19 is similar to equation number 18 except that the gx has now been replaced by 0. So this equation number 19 is a homogeneous equation associated to equation number 18. Since this equation is a homogeneous equation of nth order, therefore we can get the general solution, which is in the form of c1y1 plus c2y2 plus some terms in between plus cnyn. And this general solution is known as the yc, which is the complementary function. The yp is the particular solution of the non-homogeneous equation. How do you find the yp? This is what we're going to discuss in chapter 4.4. Section 4.4.2 shows us the method to find the yp, and the method is known as the method of undetermined coefficients. And the approach that we are going to use is specifically known as the superposition approach. In order for us to use the method of undetermined coefficients, or specifically known as the superposition approach, we need to check for two things. The following two requirements must be met in order for us to use the superposition approach. The first requirement is that the coefficients must all be constants. So that's the first thing that we have to check. Second requirement is that the gx must belong to one of these group of functions. The gx has to be a constant, example g of x equals to 4, or the gx is a polynomial function, example g of x is a linear function, or a quadratic function, or a cubic function, or the gx is an exponential function, example g of x is equals to e to the negative 2x, or the gx is a sine or a cosine function, example g of x is sine 3x, g of x is cosine 9x, or the gx is a finite sum or product of any of the above function. Example, g of x is a product of a linear and a sine function added with a quadratic function. So if the gx belongs to one of this group of functions and the coefficients are all constants, then we can use the superposition approach in order to find the yp. If one of these requirements are not met, we cannot use the superposition approach. For example, do you find out that in the differential equation the coefficients are all constants. However, the gx is a logarithmic function. Logarithmic function does not belong to one of this group of functions, and therefore we cannot use the superposition approach to find the yp. We may also encounter a problem where the coefficients are not constants, but the gx belongs to one of this group of functions. So since the first requirement is not met, then we cannot use the superposition approach to find the yp. So please remember, in order for us to use the superposition approach, the following two requirements must be satisfied. Let us now learn how to use the superposition approach in order to solve a second-order non-homogeneous linear DE with constant coefficients. The first step is to find the yc, the complementary function. How to find the YC? We start by writing down the associated homogeneous equation. In other words, you're going to replace the gx by 0. So this equation is a homogeneous equation associated to the non-homogeneous equation. And when we solve this homogeneous linear equation, we can try to solve it by using the technique learned in chapter 4.3. To find the YP, the particular solution for the non-homogeneous differential equation, we start by writing down the form of the trial YP that matches the form of the GX. I will explain this afterwards. Once we have formed the trial YP, we will notice that the YP contains unknown coefficients such as A, B, C, etc. So these A, B, C are known as the unknown coefficients. Since the dE is of second order, we need to differentiate the YP twice. And after that, we substitute YP, YP prime, and YP double prime into the left-hand side of the given non-homogeneous equation. Once that has been done, we can start comparing the left side with the right side of the equation, and from there we can determine the unknown coefficients A, B, C. We then write down the specific form of the YP, and lastly, we can form the general solution y equals to YC plus YP. Okay, these are some examples of trial particular solution. If you see the gx as a constant, let's say the gx is equal to 10, then the form of the yp must follow the form of the function gx. If this is a constant, then the yp must also be a constant, and let us call it as an e. Suppose the gx is just a linear function where the function has x of degree 1. In this example, gx is 5x. So since this is a linear function, so we expect the yp must also be a linear function in the form of ax plus b. Example number 3, let's say the gx is a quadratic function, 3x squared minus 2, and so the yp must also be a quadratic function, which in general it is expressed in the form of ax squared plus bx plus c. In example number 4, this gx is a cubic function and a function of degree 3, and therefore the yp must be of degree 3 as well, which is given by ax cubed plus bx squared plus cx plus d. Suppose the gx is a sine function, sine 4x. So how to form the yp? Firstly, we note that the constant multiplied by the sine 4x is the constant 1. So this constant number 1 will be replaced by a. Let's say the constant is not 1, suppose the constant is equal to 2. So whatever the number here, whether it's 1 or 2 or 6, you just replace it by the coefficient a. So the form of the yp that matches the function sine 4x is a sine 4x. However, we know that in our previous lesson that a sine function always goes together with a cosine function. So you have to add another term known as b cos 4x. So you have to add b cos 4x to a sine 4x. So this will be the complete form of the trial yp corresponding to the function gx equals to sine 4x. Another example, suppose the gx is 5 cos 4x. So how do we write down the trial yp? So since we have the number 5 here, so we're going to replace that number 5 by the general coefficient a, and 5 multiplied by cos 4x, so the yp will be a times cos 4x. But we already know that cosine always goes together with sine, and therefore we have to add another term which is expressed in the form of b sine 4x. In number 7, we have the example gx given by negative 3e to the 5x. This constant negative 3, or whatever constant that you have here, let's say the constant is 7. So whether it's negative 3 or 7, you just replace it by the coefficient a. And then this negative 3 is multiplied by e to the 5x, so you write ae to the 5x. Number 8, we have a product of a linear function and an exponential function. So the form of the yp will look like this. We have a linear function ax plus b multiplied by the exponential function e to the negative x. Number 9 is an example of the gx is a product of a quadratic function and an exponential function. So the form of the yp must follow the form of the gx. Here you have the quadratic function ax squared plus bx plus c multiplied by e to the negative x. In number 10, we see the gx given by a product of e to the power of 2x cos 3x. So we have a product of e to the 2x. Now this e to the 2x cos 3x will be given by e to the 2x cos 3x plus b e to the 2x sin 3x. Okay, so you have a e to the 2x cos 3x as a function similar to what we have here in the gx, but then you have to add another term involving the sine function. For number 11, we have a quadratic function, a function of degree 2 multiplied by sine 4x. So for the trial yp, you do the same thing. You write down the quadratic function multiplied by sine 4x, and don't forget to add another term involving the cosine function. So if this is quadratic, this must also be quadratic. And number 12, we have a product of 3 different kinds of functions. We have a linear function multiplied by exponential multiplied by a cosine function. So this linear function will be given in the form of ax plus b for the trial yp multiplied by e to the 2x cos x multiplied by e to the 2x cos x. But remember, you have to add another term involving the sine function, cx plus d e to the 2x sin x. So these are some examples of what the gx looks like and how to write down the corresponding form of the yp. Let us look at some questions. Solve the differential equation by using the method of undetermined coefficients. Or sometimes you are asked solve the differential equation by using the superposition approach. Question number 1, let's say you have a differential equation of second order and it is non-homogeneous. Y double prime plus 3y prime plus 2y equals to 10e to the power of 4x. Okay, so we shall start by finding the yc, the complementary function. Okay, how to find the yc? We need to write down the associated homogeneous equation. In other words, the gx for this equation need to be replaced by 0. So the equation now becomes y double prime plus 3y prime plus 2y equals to 0. How to solve this equation? We have already learned this in chapter 4.3. We start by forming the auxiliary equation, which is m squared plus 3m plus 2 equals to 0. Factorize this equation, we get a product of two factors equals to 0, m plus 1 multiplied by m plus 2 equals to 0, and we apply the concept a times b equals to 0. So if m plus 1 equals to 0, the first root is negative 1, and if m plus 2 equals to 0, the second root will be negative 2. So we have a case of distinct real roots, m1 is not equal to m2. To get y1, we write down y1 as e to the m1x. Substitute m1 into here, so you get y1 as e to the negative x. And for y2, since this is also a real number, the formula will be e to the m2x. Substitute m2 by negative 2, so we get y2 as e to the negative 2x. So we already got the two linearly independent solutions, y1 and y2. And so we call this as the yc. Yc is c1 y1 plus c2 y2, or yc is c1 e to the negative x plus c2 e to the negative 2x. So we are done with the first part, finding the yc. Let us continue to find the yp, which is the particular solution of the non-homogeneous equation. To find the yp using the superposition approach, we'll focus on the function g. G is given by 10e to the 4x. So we have to form the trial yp. what is the form of the particular solution that corresponds to the function g. Since this is an exponential function multiplied by the constant 10, so this constant 10 needs to be replaced by a general coefficient which we call it as an a. So constant times e to the 4x, therefore the yp will also be in the same form, which is a e to the 4x. Once we have formed the yp, we need to differentiate it twice because the dE is of second order. So differentiate a e to the 4x, we get yp prime equals to 4a e to the 4x. Differentiate it for another time, we get yp double prime, which is 16a e to the 4x. After this, we need to substitute yp, yp prime and yp double prime into the left hand side of the non-homogeneous equation. So this is the non-homogeneous equation. So you substitute yp, yp prime, yp double prime into this left side of the dE, which is given by this. Okay, so yp double prime plus 3yp prime plus 2yp equals to 10e to the 4x. Substitute yp double prime, which is 16a e to the 4x into here, plus 3 times yp prime, so 3 times 4a e to the 4x, plus 2 times yp, which is 2 times a e to the 4x, is equals to 10e to the 4x. Now you have to simplify the left side. After simplifying, we'll get 30a e to the 4x equals to the right side 10e to the 4x. Solving this equation, we'll get the value for the unknown coefficient a is equals to 1 over 3. So what is the form of the yp? Earlier we have formed the yp as a e to the 4x, but now we have already known the value for the a, which is 1/3. So yp will be 1/3 e to the power of 4x. So we've got the yc. Now we've got the yp. And now we can write the general solution. Y is equals to yc plus yp. So yc is c1 e to the minus x plus c2 e to the minus 2x, which is this one, plus yp 1/3 e to the 4x, which is this one. Okay, so this is the steps of how to solve this non-homogeneous linear equation. Example number 2, y double prime minus 2y prime plus y equals to 5 cos 2x. Okay, so again we are seeing here a non-homogeneous linear equation with constant coefficients. So to solve this equation, we start by finding the yc. And to find the yc, we need to form the associated homogeneous equation. In other words, you need to replace this 5 cos 2x by 0. So the associated homogeneous equation is expressed in the form of y double prime minus 2y prime plus y equals to 0. To solve this homogeneous equation, we form the auxiliary equation m squared minus 2m plus 1 equals to 0. So the left side can be factorized in the form of m minus 1 multiplied by m minus 1 equal to 0. Based on this equation, we get two roots which are both equals to 1. So m1 equals to m2 equals to 1. So we have a case of repeated real roots. To get y1, since m1 is a real number, so y1 is expressed in the form of e to the m1x. Substitute m1 by 1, so y1 is just e to the power of x. Since m2 is repeating m1, or m2 is equals to m1, so to get y2, we multiply y1 by x, which is given by x e to the power of x. So we now have the two linearly independent solutions y1 and y2. So we can form the yc, which is equals to c1y1 plus c2y2, c1 e to the x plus c2x e to the power of x. The next step is to find the yp, the particular solution of the non-homogeneous equation. Note that the gx is given by 5 cos 2x. So to form the yp, we need to write down a function which is similar to the form of the given gx. And that will be a cos 2x. So the constant 5 is replaced by the coefficient a, followed by the cosine function. So we have a cos 2x. But cos must goes together with sine, so we have to add another term, b sine 2x. So the a, you replace it by a b, and the cosine, you replace it by a sine in order to get this second term. So in other words, the yp is a sum of a cos 2x plus b sine 2x. Next step is to differentiate yp twice. So yp prime, after differentiating for the first time for the function yp, we'll get negative 2a sine 2x plus 2b cos 2x, and differentiate it for the second time, we'll get negative 4a cos 2x minus 4b sine 2x. Substitute yp, yp prime and yp double prime into the left hand side of the non-homogeneous equation. Okay, so this is the left hand side of the non-homogeneous equation. So you substitute this by yp, yp prime, yp double prime as given in this form equals to 5 cos 2x. Okay, the substitute yp double prime, which is negative 4a cos 2x minus 4b sine 2x into this part, minus 2 times yp prime, so minus 2 times, so this is the yp prime, negative 2a sine 2x plus 2b cos 2x, plus yp, so plus, so this is the yp, a cos 2x plus b sine 2x, equals to the right side, which is 5 cos 2x. Okay, so the left side is equals to the right side. We need to regroup the left side of the equation. So after regrouping, we get the term for the cos 2x and we get another term for the sine 2x. So we get negative 3a minus 4b multiplied by cos 2x plus 4a minus 3b multiplied by sine 2x is equals to 5 cos 2x. So if you compare the left side with the right side, we are going to compare coefficient of like terms. Okay, so on the left side, we have the first term containing the function cos 2x, and on the right side, we have the term also containing the function cos 2x. So again, to compare the coefficient of the cos 2x on the left side with the coefficient of cos 2x on the right side. In other words, negative 3a minus 4b is equal to 5. So that's why we have this written here, negative 3a minus 4b is equals to 5, and I call this as equation number 1. On the left side, there is a function sine 2x, and the coefficient of the sine 2x is given by 4a minus 3b. On the right side, there is no function involving sine 2x. That means the coefficient of sine 2x is 0. So we equate the coefficient of sine 2x on the left side with the coefficient of the sine 2x on the right side. So we'll get 4a minus 3b equals to 0, as shown as in number 2. So what we have now is a simultaneous equations which we can solve. So try and solve these simultaneous equations yourself, and you will get the following answers. A is negative 3 over 5 and B is negative 4 over 5. Once you've got the values for the A and the B, we can substitute into the YP. Okay, so YP initially is A cos 2x plus B sin 2x, but we now know that A is negative 3 over 5 and B is negative 4 over 5. So this is the form of the particular solution YP. So lastly, let us write down the general solution. Y is equals to YC plus YP. YC, as we know, is C1 e to the x plus C2x e to the power of x, and YP is negative 3 over 5 cos 2x minus 4 over 5 sin 2x. So this whole thing here is known as the general solution for the given differential equation. So that's the lesson for the first part of chapter 4.4. Thank you.